Hello students, this is Mr. Wilsey, and in this video I need you to take notes on this worksheet here, which I should have handed you in class. If you do not have this worksheet, then just take down as many of these notes as you can on paper. The topic of this video is factoring quadratic trinomials. You've already been doing that, but we're going to step it up a notch, okay? And this topic is probably the most challenging that we will face in Algebra 1. The most challenging skill, definitely. Alright? So let's read through the top here. A quadratic trinomial is a special kind of polynomial that we will study in more depth in Chapter 9. Put chapter in quotes because it's not like we really used the textbook. A quadratic trinomial has a degree of, well, the degree is determined by the word quadratic, has a degree of 2, and has how many terms? Well, trinomials have 3 terms. Okay? So the general form of a quadratic trinomial is, this is the way that we're going to write it, a times x squared plus b times x plus c, where x is the variable. It could be any letter, it could be P, it could be K, whatever. And A, B, and C represent numbers. And these numbers are called coefficients. So A, B, and C stand for numbers, and we call them coefficients. Now you have already been factoring quadratic trinomials. Let me give you an example of a quadratic trinomial that you've already factored. How about x squared plus 5x plus 54. That was the first problem on your homework. Sorry, not on your homework. You don't have homework anymore. On your in-class work. You factored that, and you got x plus 6 in parentheses times x plus 9 in parentheses. Okay? That's how you factored it. Now, in this case, the C was 54, the B was 5, and the A was that invisible 1. So A equals invisible 1. And if you recall, this is true of all of the factoring problems you've looked at so far. A was the invisible 1. And it was really easy to factor quadratic trinomials that had the invisible 1. You just had to find the two numbers that multiply to equal 54 and add to 5. In this case, 6 plus 9 is, I'm sorry, I totally wrote this down wrong. This should be 15, should it not? See, I just checked myself. 6 plus 9 is 15. 6 times 9 is 54. And that is the way that you can easily factor quadratic trinomials with invisible 1. Now what we're going to do is we are going to look at quadratic trinomials where A is not equal to 1. In this case, the first example that we're going to look at, A is 6. Over here, A is 10. Okay? Now, this gets really complicated in a hurry. But this worksheet, it will help to kind of dissect how to factor quadratic trinomials that look like this, where A is not equal to 1. So let's go ahead and get started. Okay? Let's look at the first example here. We want to factor 6x squared plus 23x plus 7. Now, the first step is to multiply A times C. Now, what was A, B, and C again? A is 6, B is 23, C is 7. So step 1 is to multiply A and C. So 6 times 7 is 42. Now that we have 42, we're going to do the same exact thing that we did with the 54 up here. we're going to list out the factor pairs of the product AC. So we're going to list out the factor pairs of 42. So let's start with 1 and 42, the easiest. How about -1 and -42, 2 and 21, -2, -21, 3, yeah, 3, 3 and 14, -3 and -14, 4 is 4, no, 5, 6, 6 and 7, and -6 and -7. Now, notice, of course, that we multiplied 6 times 7 to get 42, and of course, 6 and 7 appear in our list of factor pairs. Now, just like we did when we were factoring quadratic trinomials that look like that, we are going to identify the factor pair whose sum is b. Right? Which of these factor pairs add up to equal b? Well, 1 plus 42 is 43, -1 plus -42 is -43, 2 plus 21 is 23. Oh, and that's it. I'm done. Right here. 2 plus 21 equals 23. And our goal here was to identify which pair of numbers adds up to b. b is 23. So we're done. Okay? We are done. 23, well, we're done with that part, sorry. 23 is b. So we have found our pair of numbers. Okay? Now, let's look at step 4. Step 4 is what I like to call bust up the b. This means split the b times x term into two terms that add up to it. Split the bx term. Now, let me show you what I mean by that. b times x, that term is 23x. We are going to split it up. We are going to split it up into 2x plus 21x. Okay? 2x plus 21x is the same thing as 23x. Now we're going to keep everything else the same. We're going to keep the 6x squared out front, and we're going to keep the 7 out back. Okay? So all I did here was write the original quadratic trinomial, except I split 23x into 2x plus 21x. That's all I did. Now, let's look at step 5. Step 5, we're going to use a skill that you've already developed and hopefully have become proficient at by now. We are going to factor out the GCF, the greatest common factor, of the first two terms. Okay? So let's just look at the first two terms. So I'm going to hide the second two terms. 6x squared plus 2x. Let's find the GCF of those two terms. You should be able to see this in your head. They both have an x in common. They both have 2 in common, right? So 2x is the GCF. Now I'm going to factor that out. What's left over after I factor out 2x from 6x squared? Well, 3x. What's left over after I factor out 2x from 2x? Interesting. 1, right? Because if I were to multiply that back in, I would get 2x back, okay? So, after you've factored out the GCF from the first two terms, then we're going to factor out the GCF from the last two terms. 21x plus 7. Let's see, what's the GCF here? They don't have an x in common. They do have a 7 in common, right? 7 times in parentheses. What's left over after I factor out a 7 from 21x? Well, 3x, right? 3x. What happens if I factor out a 7 from 7? 1. Okay, 3x plus 1. Now, of course, we had a plus sign in the middle originally. We need a plus sign down here. Okay? Now, look at this magic that just happened. There's a 3x plus 1 right here, and there's a 3x plus 1 right here. Interesting. That is interesting. Now, since 3x plus 1 appears here and here, we can factor out the 3x plus 1. Watch what I mean by that. This is step 6. Factor out the common binomial. 3x plus 1 inside of parentheses times what is left over when I pull 3x plus 1 out of both the 2x and the 7? Well, 2x plus 7. Okay? And that is it. We are done. This is the factored form of 6x squared plus 23x plus 7. Now, I hope you realize, first of all, how difficult this is. Difficult in the sense that there's a ton of steps and there's a lot of possible ways to go wrong. But also, look at how cool it is. Look here, the 3x plus 1 just magically popped out of nowhere in both places. Isn't that cool? Now, of course, the reason that we got a common binomial, 3x plus 1, is because of this little magic we did here. We knew that the best way to split up 23x into 2x plus 21x, out of all these possible ways to split up 23x, this way will lead to us having this common binomial of 3x plus 1. Okay? Now, what I want you to do now is try to factor this quadratic trinomial on your own. Alright, let's move on to example number 2 now. We're going to do the same exact steps that we did in the last problem. Alright? So 10h squared plus 31h minus 14. Now remember, the first step is to multiply the a times the c. So 10 times negative 14 is negative 140. Now we're going to list out the factor pairs of this product. And we're going to try to find which pair of numbers adds to equal 31. Remember, A, B, and C. Let's see, 1 and negative 140, negative 1 and positive 140, 2 and negative 70, negative 2 and positive 70, 3, no, 4, yeah, 4 times what? Let's see. If you don't know what the pair, what the second number that goes here is, just take negative 140, divide by positive 4, negative 35. Negative 35. So that means that negative 4 and positive 35 will also work. 5, yeah, 5 and what? Negative 140 divided by 5 is negative 28. So 5 times negative 28 will give us back negative 140. Negative 5 and positive 28. How about 6? No, 6 won't work. 7. Yeah, 7 and what? Let's see. Negative 140 divided by 7. Negative 20. So negative 7, positive 28. Will 8 work? I don't know. Let's check. Negative 140 divided by 8. That's a fraction. We want integers, so the fraction is not going to work. So negative 140 is not divisible by 8. What about 9? No, 10. Yeah, 10 and negative 14. And then negative 10, positive 14, 11, 12, 13, 14, and then we're back to where we started with 14. Okay? So this is a complete list of all the factor pairs of negative 140. So what we're going to do now is try to figure out which pair of these adds up to equal 31, which is B. 1 plus negative 140 is negative 139. Negative 1 plus 140 is positive 139. 2 plus negative 70 is negative 68. Negative 2 plus 70 is positive 68. 4 plus a negative 35 is negative 31. Oops, that should be a plus sign. Negative 4 plus 35 is 31. 5 plus negative... Oh, wait. I can stop right here because I found my 31. I found my 31. Negative 4 plus 35 equals 31. And 31 is B. Okay? So we found our magic numbers negative 4, and 35. We're going to use those magic numbers to bust up the b. Okay? Step 4 is bust up the b. So we're going to replace 31h with negative 4h plus 35h. Then we're going to keep the negative 14 the same, and we're going to keep the 10h squared the same. Okay? So we have successfully busted up the b. Remember that we found negative 4h plus 35h, because that is the same thing as 31h. And the magic pair of numbers is what you use to bust up the b. Now, the next step, again, is to factor out the GCF of just the first two terms. So I'm going to hide the second two. Now let's find what the GCF of 10h squared and negative 4h is. See, they both have an h, and they both have a 2, right? So 2h appears to be the GCF. So 2h times what will get us back what we started with? 2h times 5h will give us back 10h squared. 2h times negative 2 will give us back negative 4h. Okay? So all I did here was factor out the GCF of those two terms. Now, let's look at the last two terms. 35h and negative 14. What's the GCF here? They don't have an h in common. They don't, well, it might be hard to see what the GCF of these two numbers are. What you can do, though, is recognize that in order for the rest of this to work, you need to have a common binomial. The common binomial needs to be 5h minus 2. Just like in the first problem, the common binomial was 3x plus 1. So let's just assume that we did all this correctly. We found the correct pair of magic numbers. Our common binomial needs to be 5h minus 2. The question then becomes, what is the GCF? What would I need to factor out of those two terms to get 5h minus 2? Well, how about 7, right? 7 times 5h will give 35h. 7 times negative 2 will give negative 14. So that's a quick way to find out what the GCF is. You just have to realize that in order for this to work, we need a common binomial. So just assume that the common binomial is the same as it was over here, because it has to be. Okay? Now we had a plus sign up here, so we need a plus sign over here. Now, the last step is to factor out the common binomial, which is 5h minus 2 inside of parentheses. What's left over after I factor that out? 2h plus 7. And ta-da, we are done. Okay? Again, you can multiply this to check to see that we get 10h squared plus 31h minus 14 back. So what I want you to do now is apply the same exact process to the U-try problem over here. Try and factor that out. Pause the video. Take some time to do that. Alright, now let's move on to example number 3. Example number 3. 20w squared minus 45w plus 10. Alright, now in this case I give you a step 1/2. I give you a step before we even start multiplying a times c. In this case, the step 1/2 is to factor out the GCF of all three terms, just like you've already been doing, right? You have three terms, try to see if there's a GCF to all of them. Now, this should always be your first step. In example 1 and example 2, there was no common factor of all three terms, but in this case there is. So you always need to keep an eye out for that. In this case, the common factor of all three of them appears to be 5, right? All three of those numbers have a 5 in common. So if I factor out a 5, what's left over? Well, 5 times what equals 20w squared? 4w squared. 5 times what gives negative 45w? Negative 9w. And 5 times what equals 10? Positive 2. Now, we've factored out the GCF. So at this point, we do all the same steps that we did in examples 2 and example 1. So multiply a times c. Now notice that we have a new a and a new c. A, in this case, is 4. B is negative 9, and c is 2. So let's multiply a times c. 4 times 2 is 8. Let's list out the factor pairs of 8. 1 and 8, negative 1 and negative 8, 2 and 4, negative 2 and negative 4, and that's it. Now, which pair of these numbers adds up to equal b, which is negative 9? Well, right here, negative 1 plus a negative 8 equals negative 9. So that's our magic pair of numbers. We're going to use these magic pair of numbers to bust up the b. So we're going to replace negative 9w with negative 1w minus 8w. Okay? Because these together is the same thing as negative 9w. So we busted up the b. We're going to keep the plus 2. We're going to keep the 4w squared. And important, we're going to keep the 5 out front. 5 times in parentheses, all that stuff. The 5 is just tagging along for the ride. Okay? Now, let's factor out the GCF of the first two terms. 4w squared and negative 1w. Again, I'm just going to keep the 5 inside of parentheses because it tag along for the ride. We don't want to forget about them. What's the GCF of the first two terms here? Let's see. It looks like the only thing they have in common is a w, right? So w times in parentheses what? W times 4w will give us back 4w squared, and w times negative 1 will give us back negative 1w. All right, now let's look at the last two terms. Now again, we know that we need a common binomial. So let's assume that we've done everything correctly so far and just put down a 4w minus 1 inside of parentheses. What needs to multiply 4w minus 1 in order to get this back? Well, let's see here. What times 4w will give negative 8w? Negative 2, right? Negative 2 times 4w will give us back negative 8w, and negative 2 times negative 1 gives back positive 2. Okay? And then one last step, factor out the common binomial. So again, we're going to have a 5 hanging out front here. The common binomial is 4w minus 1. And what's left over is w minus 2. And that's it. We are done with that one. Okay? Now again, this example was slightly more challenging than the other ones that we looked at because we had to factor out the GCF from all three terms at the very beginning. It was also slightly more challenging than the other ones that we looked at so far because of right here. We would have had to factor out a negative number in order to get the common binomial that we want. But instead, the way that I showed you, as soon as we find the common binomial here, if you assume that the common binomial is also here, which it needs to be in order for this to work, then it's clear that we need to factor out a negative number in order for these two to match. And as you practice some more with this, you'll see why that is a useful trick to have up your sleeve here. Okay? Now what I want you to do is, well, we're done with the video, but I want you to try this example here. Again, your first step is going to have to be to factor out the GCF of all three terms before you even get started. And as soon as you get done with that, I want you to flip the paper over and try to factor these three quadratic trinomials using the method that we just learned. So I hope this video helped to explain this rather challenging skill, and I hope that you're ready to practice the skill in class.